Hello everyone, welcome to UrbanSubnet. Today we're going to create a network here that we see on the screen. The topology is we have a router 1, we have 3 switches, and we have router 3. So what we're going to do on the routers is we're going to create some sub interfaces to the switches. We're going to use layer 2 encapsulation on the interface links that will configure them to transport layer 3 traffic across these links. And from the switches to the router, these are going to be trunk links here. And then the router is going to have a sub interface. And we're going to enable EIGRP routing throughout the network so we can have connectivity from end to end. On the switches, we're going to create some VLAN interfaces. We're going to create the port channel interface. We're going to create the trunk ports, and we're going to enable EIGRP routing. So what this might simulate here is this network could be in your building somewhere, and let's say switch 1 is on the first floor, switch 2 is on the second floor, switch 3 is on the third floor. Then off of these switches, as you can see, there's plenty of ports on the switches, so those ports can connect computer devices. They can connect voice over IP phones, or they may even connect servers. But that's what we're gonna configure the network, so anything that are attached to these switches will be able to communicate with each other on the first, the second, and the third floor. The routers themselves, we're just gonna have the routers using as a point of routing between VLANs and between the switches. And we also used, if this was, in the real world network, the router here, one of these routers may have a connection out to the internet, or one of these routers may have a connection over to a branch site somewhere else. Okay, so let's get started. First thing we'll do is we'll start with router number 1. So let's go ahead to router 1, config T, enable. Config T. Now first thing, let's do some little house cleaning here. Host name router 1, and then we're going to go into the interface. So the first thing we're going to do is we're going to set up the sub interface. So we're going to go into interface FA 0/0. Then we're going to do no shut on the interface. Then we're going to interface FA 0/0.10. This is going to be our sub interface here. We're going to do encapsulation .1Q10. So what this command here is telling us, or what it's going to do on this router, is going to create an encapsulation for layer 2 protocol on this interface, and it's going to be .1Q protocol, and we're going to be running this connected to the switch on VLAN number 10. So that's what that 10 is there for. We put a description, connect to switch 1, and then we're going to do a no shut. Alright, so we have set that up, and we also want to put the IP address on the sub interface. So we're going to put IP address 10 10 10 1 255.255.255.0. Alright, so we have that set up here. And the next thing I'm going to do is we're going to do an interface loopback 0. That interface is going to have an IP address. And then we're going to do interface loopback 5. It's going to have an IP address of Actually, we're going to do this one here. This one's going to be 172.17.5.100. It should be IP address. Alright, so now we're going to do exit, show IP route. Alright, so this show IP route is showing our connected interfaces 1.1.1.1, 10.10.10.1, 172.17.5.100. So that was done on router number 1. So we're going to go over to switch number 1. And we're going to go enable. And the first thing we're going to do on the switch is we're going to set up a trunk interface to router number 1. So we're going to go into config t intfa 0/1. And this one we got to do, we have to do the same encapsulation. So we're going to do switch port because we're working on the switch now. Switch port trunk encapsulation dot 1Q. So we set the encapsulation on the switch port. We're going to do switch port mode trunk, and then we're going to do no shutdown on the switch port. Now, switches are a layer 2 device, so you set up the IP addresses and the routing is a little different. So what we're going to do on this switch, we're going to do config T, and we're going to do interface VLAN 10, and then we're going to do IP address 10.10.10.5. And when you ever make a VLAN interface on a switch, remember you have to unshut it. You have to do the no shut on that interface, otherwise it will not come up automatically. And that could cause problems on your network, of course, if you forget to unshut the interfaces. So now that we've done that, we're going to exit from the VLAN interface. And I'm going to show you a couple of things here in a minute. But the first thing we're going to do next is we're going to try to ping the router. Now we know we're directly connected to the router. We do show CDP Neighbor. Let's see if we can see the CDP. We have router 1 off of interface 0/1. So we see our router is connected. So now let's see if we can reach the router. And we could not. Even though we have the ports configured and the ports up, we do show CDP Neighbor on the router. The router is seeing our switch right here on this port right here. But at the moment it is not up. So what we have to do on a switch, when you create when you want to send traffic off of the switch to the router, you have to first do a gateway, a default gateway for the switch. So first we're going to do config T, then we're going to do default. Actually, we need to do an IP default because we run an internet protocol. IP default gateway, and then we're going to put the router's address of 10.10.10.1. Okay, so now we see that we added the default gateway. So we go back to and we're going to try to reach the router again. And lo and behold, it does not work. So I'm just trying to bring this up so everybody will understand. When you're working on a switch and you're trying to communicate with the router, there's some very important things that you need to do before you're going to be able to successfully ping. Now I'm going to go ahead and show you part of, we're going to fix this here. We're going to resolve this problem. The first thing I'm going to do is we're going to group a couple of ports together, and we're going to put them in this particular VLAN. So let's go to config T, and if we want to add a port to the VLAN. So what I'm going to have to do is get a port that actually has some connectivity to it. So we're going to do config T, interface range FA 0/10 through 12. We're going to do this port access VLAN 10. I'm going to put the VLAN 10 on these ports that I know are up and have activity on them. And then we're going to no shut those ports. We may get some messages here momentarily concerning those ports. So see, yeah, we got the native VLAN mismatch messages coming in already. So let's do in. Let's try that ping again. And now our ping is successful. So what actually had to happen here is we had to get some ports that were actually actually connected, and put those ports into VLAN 10, and then that brought the VLAN up and it brought the VLAN interface up. So now if we do a show VLAN brief here and see what we have. We have VLAN 1 is the default VLAN, VLAN 10 is the VLAN that we created, and now we have ports in VLAN 10. Now I had put port number 9 in VLAN 10, but the reason why that didn't work, port number 9 is not connected to anything. So port number 9 didn't actually come up. Ports 10, 11, and 12 are connected to something. So those ports came up, and then we were able to send traffic to router 1. So we can ping router 1, and then router 1 can ping 10.10.10.5. Alright, so that is successful. So we want to do a copy run on the router, and that's looking good. So now on the switch, we created if we do a show IP interface brief on the switch, we have VLAN 10 with an IP address on it, and it's up and it's up. Now what we're going to do next is we're going to work on our port channel interfaces. Didn't mean to move that. But yeah, we're going to work on the port channel. So the port channel goes between switch 1, switch 2, and then switch 2 and switch 3, and there's one from switch 1 to switch 3. Now on our port channel interface, what we have going is the port channel will consist of 3 interfaces. The interfaces we're going to use are going to be 10, 11, and 12. As you can see, they're up. So we're going to take 10, 11, and 12, which are 100 megabyte ports, individual ports right now. We're going to combine them into one port to create like one large port between switch number 1 and switch number 2. So that's going to go right here between switch 1 and switch 2. And then this is how we do that. Let's start on switch 2 first. We're getting these messages here for VLAN mismatch on those ports. So we're going to go config T, interface range FA 0/10 through 12. Do switch port. Switch port trunk encapsulation dot 1Q. So switch port trunk encapsulation dot 1Q, switch port mode trunk, and then we're going to put them in a port channel. So we're going to do channel group 10 mode active. So when we do a channel group 10 mode active, it's going to create the port channel for us. And the port channel protocol we're using is called Link Aggregation Protocol, and it's short for it's LACP for short, LACP for short, Link Aggregation Control Protocol. So that's the port channel protocol that we're using on this particular port channel that we're setting up. So now we can go to in here, and we got to create a port channel interface to add this, to make this port channel come up. So what we will do is we're going to go config T interface port channel 10. We're going to do encapsulation, no, I'm sorry, switch port trunk encapsulation dot dot 1Q, switch port mode trunk. Okay, so now we have that done. Now if we do our show, we want to see what our port channel looks like. We do show ether channel summary, and our ether channel summary says we have a port channel number 10. The status is layer 2, and it's down because there's nothing on the other end. Now we have our interfaces 10, 11, and 12. They're in the W state, which means they're waiting to be aggregated. So these ports are individual ports now, but they're waiting to be combined together. If we do show interface FA0/10, we see the interface is up and it's connected to the other end, and the bandwidth is 100 megabytes, because you see right here, full duplex, 100 megabytes a second. So what we want to do is we want to combine this with the other two ports to make this a 300 megabyte link between switch number 1 and switch number 2. So in order to complete that, we have to go back to switch 1 and T interface range FA0/10 through 12, and let's do switch port trunk encapsulation dot 1Q. Then we're going to change this to a trunk port, switch port mode trunk. Okay, and then we're going to add it to the channel groups, which is the port channel, but the command on the interface is channel group 10 mode active for the LACP protocol. So it's creating a port channel for us. Now what we would see is aggregating the ports. When it says creating a port channel, it's going to aggregate them together. We're going to come out of here. We're going to do config T int PO. PO10 is an abbreviation for the word port channel. This port channel is going to be a switch port trunk encapsulation dot 1Q, switch port mode trunk. So we created a port channel interface here, and now let's see what our port channel is telling us. Alright, Alright, so now in our port channel we have a layer 2 for the capital S, means layer 2. We have a capital U, which means it's up, so in use. In use is actually up. So we have a layer 2 port channel in use. We have ports 10, 11, and 12. They have a capital P, so they're bundled into port channel right now. So if we do a show interface brief here, let's show IP interface brief, we see our ports here. And down at the bottom we see our port channel right here. So now if we do a show interface PO10, we see the bandwidth on our port channel is 300 megabytes. It's running at full duplex. It says 100 megabytes a second, but it's actually 300 megabytes. Because this is our bandwidth here. This is just telling us the type of port that it would be. So it's 100 megabyte ports, but we have 3 of them together. And you can see the members in this channel is 10, 11, and 12. Okay. And there you can see some traffic statistics here, packets in and packets out. So we accomplished that. So that's a good thing. So next we're going to go back to switch number 2, and we're going to fix a couple of things here, because you notice something about switch 2. Switch 2 can communicate with switch 1 and only to switch 1. It can only communicate through the port channel interfaces. So what we want to do, what if there is some computers that are connected to switch number 2 and they need to talk to router number 1 for whatever reason. They will not be able to do that at the moment, because if we go to switch 2 and we ping 10.10.10.1, which is router 1's IP address, it doesn't even recognize it. Okay, so what we're going to do here is we're going to go to config T. We're going to create interface VLAN 10. Okay, and then we're going to give our VLAN 10 an IP address of 10.10.10.6. Okay, so we've done that. And now, remember, we have to, one of the things that we must do when we want a switch to be able to communicate outside of its boundaries is we need to put a default gateway on it. So we're going to do config T IP default gateway, and that's going to be 10.10.10.1, because we got the switch port interface on there. And then the last one of the other things that we need to do also, remember, before the switch can ping, we have the interface, the VLAN interface with the IP address. So we got a layer 3 interface on the VLAN 10. We have the IP address and we have the default gateway assigned, but we still do not have a VLAN 10. So if we do this here, show VLAN brief. Well, actually, we do have VLAN 10. So VLAN 10 is created. So we have VLAN 10 created now. So we theoretically should be able to ping 10.10.10.1. And we can. So now switch number 2 can communicate through switch 1 to router 1. So that is good. So let's go to router 1 and see if router 1 can .10.10.10.6. This is the IP address for switch number 2, so we have communication. So now if router 1, let's say router 1 had another interface, show interface brief. Let's say the serial interface on our router was connected to Verizon, and then Verizon gave us internet access to the internet and the rest of the world. Now the computers off of switch number 2 and switch number 1 would be able to connect to the router or send traffic to the router that could then be forwarded out to the internet. So we have that done. So now on switch 1, we have the Ether channel set up, and we have the VLAN interface is done. We had the port channel, Ether channel set up. We had the trunk ports done, but we haven't done any routing yet. So before we do the routing, let's go ahead and finish our port channel configuration, because remember, we want to do a port channel here, port channel here, and a port channel here. So let's go to switch number 3. And then on switch number 3, we're going to use ports 13, 14, and 15. So we're going to do interface range FA0/13 through 15. And then we're going to do channel group 10. Oops, and before we do that, we want to do switch port trunk encapsulation dot 1Q switch port mode trunk. Then we want to do channel group 10 mode active. Okay, so there we go. So now we got those in the channel group, and then we want to, on this one, we're going to create 2 VLANs. So we're going to create config T. So we're just going to do VLAN 10. That's creating a VLAN 10 interface. We're not going to do anything now. We're just going to create that interface. And then, now you can name your VLANs. Let's say this VLAN right here, let's do name. This is going to be for accounting. So that would be the accounting VLAN for the staff members that work in accounting. And then we're going to do config T. We're going to create VLAN 20, and then VLAN 20, we're going to name that VLAN, just say management VLAN. Okay, and then we're going to exit out of that, and next we're going to do interface VLAN 20. Interface VLAN 20. And then we're going to give VLAN 20 an IP address of 20.20.20.5. And we're going to do no shut. And we're just going to leave that like that for the moment. And let's go here. And we're also going to do a big T. I'm going to set up a port channel to switch number 2. That first port channel is going to switch 1. So let's do this here. Oops. Interface range FA0/16 through 18. Switch port trunk and encapsulation dot Q mode trunk. We're going to do this one. It's going to be channel group 20, oops, channel group 20, mode active. It's a good thing it lets you know when you don't complete commands, because you know sometimes you're just hammering out commands and you can skip some specific things, and that would make your configuration not good. But in this case, the switch actually told us that we didn't complete the command. So this is going to, let's do one more thing here, config host, because we're on switch number 3. Change it to switch 3 so we'll know where we're at. Now let's go back to switch number 2. T host switch 2, and we're going to do interface range FA0/16 to 18, switch port trunk and station dot 1Q. Then we're going to do switch port mode trunk, and that looks good for those. And then we're going to create, oops, we forgot one thing. Interface range, we're going to do channel group 20 mode active. Alright, so there we go. So now we're creating our port channel. Now we're going to exit here, and we're going to do interface PO20 switch port trunk encapsulation dot Q switch port mode trunk. Okay, so we should be done there. And we're going to see what our port channel looks like. Show ether channel summary. Alright, so we have on switch 2, we have 2 port channels now, 10 and 20. They both are in layer 2 and they're up, and these are the ports that are assigned to those port channels. So we got the port channel up between 2 and 3. Now we have to make sure we have a port channel up between 3 and 1, because we got it up between 2 and 1 also. So if we go to switch number 1, we show ether. You see we only have 1 port channel. Alright, so this is the kind of work you'd be doing when you're working as a network engineer and you're helping to build up the network. So now let's make sure we go on switch number 1. So we have to put our configuration to switch number 3. So let's do config T, and let's just check one thing on switch number 3 here. Show yeah, we're going to have to change this port channel number here, because well, actually, we may not have to change this port channel number. We may not, because we'll just have port channel 10 going in this direction, port channel 10 going in that direction. So let's see if that'll work for us on switch number 1. Alright, so switch 1, we're going to do interface range FA0/13 to 15, switch port trunk encapsulation dot 1Q switch port mode trunk and channel group 10 mode So I think we may have, I think that may not work for us here. Let's take a look here. Yeah, I think we're going to have a problem with that. So if we go to show ether channel summary, yeah, the second set of ports did not come up. Alright, so what we're going to do, that's fine. We will go here. We're on switch number 1. And we're just going to do config T interface range FA 0/13 to 15. And we're going to do no channel group 10. And we're actually going to put these ones in channel group 30 mode active. Okay, there we go. Now we need to go back to switch number 3 and take those ports. So we're going to do config T no int PO 10, and we're going to do interface range FA 0/13 to 15, and we're going to do no channel group 10, and then we're going to do channel group 30 mode active. Alright, so now we interface PO 30 switch trunk encapsulation dot 1Q switch mode, just port mode trunk. Alright, and now let's see what number switch number 1 tells us here. Show ether channel summary. Alright, so we have the ports here, but something isn't correct because they're down. So we have ports 13, 14, and 15, and then on switch number 3, let's do a show ether channel summary. Show interface PO 30. Downline protocol is down, said it's not connected. So did I shut the ports down? Let's do this here. Config T interface range FA 0/13 to 15, and let's do no shut, and then let's go to switch number 1. Okay, wait a minute, ports came up. So that's a good sign. See, the ports are coming up and our port channel is coming up. So that's a classic mistake we make in the networking, where we forget to unshut the ports, which is something I mentioned earlier in the video. Make sure you unshut your ports. And I failed to do it myself. So when no one is perfect, so let's do a show ETH ether channel summary. Okay, folks, now we're looking good. So we got port channels 10 and 30 up on switch number 1. We have port channels 10 and 20 up on switch number 2. And show ether switch number 3 have ports channels 20 and 30 or up. Alright, so that's great. Now, one last thing on switch number 2. We need to show IP interface brief. Alright, so on switch number 2 we have VLAN 10. On switch number 1, switch number 1 here, we have VLAN 10. Alright. And switch 2 we have VLAN 10, and switch 3 we have VLAN 20. Alright, so next thing we want to do, we have a router hanging off of switch number 3. So we want to set this router up here to communicate with switch 3, because we know switch 1 and 2 can ping to router 1. So let's go ahead and get router number 3 set up here. And router number 3, we can do a show CDP Neighbor, and we don't see anything. So let's go here and take a look on router number 3. We're going to go config t intfa 0/3. IN/0/1. There we go. Okay, so now let's do a no shut on that interface, and then we're going to do INTFA 0/1.20. Now, what this is telling us here, these messages come up. It's telling us that the line protocol and interface for Ethernet 01 changed to up. So what that is telling us is that there is something on the other end of this interface that it's plugged into that is also up. So we see that the line protocol is up. So basically it's just telling us that the switch port that is plugged into over here is up. So we can create our sub interface, because remember, from the router to the switch, the router is a layer 3 device. The switches, we're running it as layer 2. So what we're going to do is we're going to create this interface here. We're going to make it a trunk interface between switch 3 and router 3. This would allow the VLAN traffic across to the router, and then the router can send the traffic back if it needs to. So we got our FA 0/1.20 for the sub interface. So now we're in the sub interface. You can see right here it says sub IF for sub interface. We're going to do encapsulation dot 1Q20 for VLAN 20. We're going to do IP address. Now remember, we put an IP address on switch number 3, and that IP address was 20.20.20.5. When I number my devices, I use number 1 for the router, and I start my switches off with number 5. That is in case I have more than one router. I could use maybe .2, 3, 4 for the various routers. But of course, I start with .5 for my switches. So let's go back to router 3, and this IP address is going to be 20.20.21.0. Okay, and we'll do no shut. I think I already did that, but I'm just a creature of habit here. Alright, so we have that done. And now if we go to switch number 3, we want to see if we can ping 20.20.20.1. Alright, the ping is not working. So now if you're at work and someone brings this up, you get a ticket or whatever, or someone says, hey, we cannot reach this router, or this devices off the switch cannot reach the router or the internet. You need to troubleshoot that scenario. So the first thing we want to look for is the default gateway, because that's what the switch needs to get out. So we just show run pipe include, and we don't have a default gateway set up first, so we're going to do config t, or oops, that's going to take a second to die there. I should have, they didn't know IP domain lookups. So while it's trying to figure out what this means that I mistyped, that was pretty fast. Okay, so let's start over again. Config t IP default gateway, and the IP address to the router is 20.20.20.1. So we have that, and now let's do a show VLAN brief. VLAN 22. That is interesting. Show IP interface brief. I created VLAN 20, ports 19, 20, and 21 are in VLAN 22. No, these are in VLAN 22. Okay, but we have VLANs 10 and 20. Okay. Oh, that's interesting. All right. Let's do a ping 20.20.20.1, which is our router's IP address. And still, it is not working. So what we need to do on switch number 3, show either channel summary. Okay, we're troubleshooting why we cannot ping router number 3, which is 20.20.20.1. Alright, as you can see, our ping is not going through, and we set up our sub interface and our encapsulation on the router. We set up the VLAN interface on the switch, and we set up the default gateway. But now, what we didn't do, let's take a look at our show, our interface number 3. I did a show run on interface number 3 here. And there is something very wrong with this interface right here. I mean, the interface is up because we can see our router on the other end, but it's not configured properly. So we're going to go into config T, and we're going to do intfa0/3, and we're going to do switch port trunk encapsulation dot 1Q. Very important, very important. I mean, you could spend all day trying to figure this out in some cases. Well, I mean, you shouldn't, but there are cases where you might miss something like the trunk encapsulation not being set correctly in the switch port mode trunk. So, sometimes when you're at work and you're looking at some troubleshooting stuff, and you got people, eagerly anticipating you getting that interface up or getting the network up, because the users cannot get to the internet, or they can't get to their files, or etc., etc. And maybe there was a new switch put in last night and everything looked good. When they put it in, the interfaces were up because FA03 is up, but it's still not communicating properly. So that's what happened. It was not communicating properly. So now that we added the encapsulation.1Q in the switch port mode trunk, let's see if that has helped us out any with getting the connectivity established to the router. So we'll try our ping again. and now it's working. Okay, so see, we went through the configuration. We checked everything. We checked the router. We went to router 3, and we checked on the router. We checked that the sub interface was .20 and the encapsulation was .1Q20 for VLAN 20, and the IP address was correct. We did various checks on the switch because we wanted to make sure we had the default gateway. So we did a look for the default gateway. We seen that wasn't there. We added the default gateway, and we added VLAN 20. Make sure VLAN 20 is there. So we found out what the problem was. The problem was the configuration on FA03, which was the connecting link to the switch. So FA03 is this link right here, that goes down to the router. So now that we got that configured properly, we can move on with our task today. So our next task is end-to-end connectivity. And what I mean by that, can router 1 ping router number 3? Or can router 3 ping router number 1? So ping 10.10.10.1. So we get a U, a dot, a U, a dot, and a U. The U means unreachable. That means it might be out there, I just can't reach it. Okay, as like just getting a single dot. So it is unreachable. So the first thing we need to do to start making this work is we're going to configure our dynamic routing protocol, EIGRP. So on router 3, we're going to do config T router EIGRP, and you can put any number here, but you got to put a number for the autonomous system. So now if you press the question mark here, you could actually put a word there also if you want to use a name instance, but we'll just use a number. So let's just pick a random number of 200. Alright, so we're going to be, okay, so we're on the switch. Well, I actually thought we was on the router, but we're on the switch. So we got, when you enable routing on a switch, you have to do this. You have to do IP routing first, because remember the switch is a layer 2 device. Switch is a layer 2, routers are layer 3. EIGRP protocol is a layer 3 protocol. So now we can do EIGRP 200, and then we want to do networks 10.10.10.0 0.0.255. We want to do network 20.20.20.0 255 for the network, and we want to do the same thing on, we want to do the same thing on switch number 1. So we're going to come up here to switch number 1, config T, we'll do IP routing, and then we're going to do router EIGRP. Now the difference in EIGRP, this number is important for your network. Any device that you want to be running in this network with EIGRP, you have to use the same number. So we picked number 200, so that is our autonomous system number. So we're just going to that, and then we're going to do network 10.10.0 255, and then we want to do the network 20.20.20.0 255, and then there's something I forgot to do on the other one. No AutoSummary. So we have that set up here, and then let's go back to switch number 3. No, I'm going to do router EIGRP 200. No summary on that one there. So we're also going to do that. And then our other switch was switch number 2. And we're going to do config T. We're going to do IP routing. Oops. And then we're going to do router EIGRP 200. Oops, no, auto summary. And as you can see, we already formed an EIGRP neighbor here with one of the other devices. And we'll do network 20.20.20.0. And then we will do the same thing on our router, because if we go back to where we're on router 3 and we ping 10.10.10. Oops, 10.1. You see there, it's still unable to reach router number 1. So what we will do here is we're going to do config T, and then we're going to do router EIGRP 200. And then we're going to do network 10. Then we're going to do network 20. We should see a neighbor form or switch number 3 here, which it did. No auto summary. Now on router number 3, we have EIGRP running, so we can do a show IP route. And right now on our devices, the routing table is only connected devices. So if we do a show IP EIGRP neighbor, we do have one neighbor formed here. So we have a neighborship with switch number 3, because switch number 3 IP is 20.20.20.5. So now what we want to do is we want to go to, if we go to switch number 1, which doesn't have a neighborship with router number 1, we should be able to ping router number 1, because we have EIGRP running right here, right now. So let's go ahead and test our configuration. From switch number 1, we want to ping 20.20.20.1. I'm getting some kind of message here. There, ports 24 and port 30. So we have something flapping between port 24 and port 30. We will have to troubleshoot that in a moment and see what's going on there. I think, let's do this here. INTFA 0/24. Why did it do that? Okay. Alright. That may put an end to that. We'll have to see. Now let's go up here to router 1, because that ping still did not work. From switch 1 to router 3. Yeah, we didn't the ping did not go through. So let's see if we can ping switch number 3, which we also cannot ping, and we're getting some MAC address flaps on port 03 and port 023. Okay, yeah, we're going to have to troubleshoot that. Let's go up here now. FAT router EIGRP 200 network 10.10.10.0 0.0.0.255, and then network, I think we had a 172.17.0. This is show IP route. Show IP route on this router. We had a 10 and 10. It's only showing as connected route, so we may have to figure out what's going on our other switches here, because we're getting some MAC address flap errors here. Yeah, so okay, we're going to figure out what's going on with this MAC address so we can get our pings to go through and get our EIGRP network up and running correctly. Alright, so let's take a look here. The neighbor came up on switch 2. Switch number 3 is the one that's giving us some port 03, port FA23. So let's do a show run INTFA0/23. It says it's in VLAN 20. So let's config T INTFA 0/23. And there's two ways you could solve this. If you wasn't using that port, you could actually shut it down, but then you may have to use it again later and you have to readdress this problem again. So let's do this. Let's take this and flap it between 3 and port channel 30. Let's do smart access VLAN 1. Let's see if that does anything there. And let's do our show IP EIGRP neighbor. So he has a neighbor with router 1. This is switch 3. He has an EIGRP neighbor with router 1, and that makes perfect sense. Switch number 2. Okay, when we got rid of that MAC address flap, looked like we had a neighbor come up here. He is neighboring with router number 1. So switch 2 says he has an EIGRP neighborship with router number 1. So switch 2 says it has a neighborship with router 1, and switch 1, is this new or is this port channel 30 and port 24? Let's see something here. This is switch 1. Switch number 2. And switch number 3. Okay. So he does have his routing table here, but he doesn't have a routing table for the 10 network, so that's why they cannot reach. So switch number 3 doesn't have a routing table for the 10 network. So if we go to show VLAN brief, okay, so what we got to do, now remember we put the accounting VLAN here, so what we're going to do, config T interface VLAN 10, because we put the accounting VLAN there, but we never gave it an IP address. So let's give it an IP address of, IP address of 10.10.10.7, 255.255.255.0, because I do believe we, alright, so see, now we're up and we got another adjacency up. We got some more EIGRP up and running here. So what happened is, now we have an adjacency with router 1, switch number 1, switch number 2. Alright, so now let's see if router 1 is able to ping. We're trying to ping router 3, 20.20.20.1. Now we can ping. Alright, so we had to troubleshoot that issue. Well, I had to troubleshoot a couple of issues. We were getting a MAC address flap error, which was telling us the MAC address, the same MAC address is being seen on more than one port. So we had resolved that issue by taking the port and putting it into VLAN number 1. Because here we are, yes, MAC address flap. It says that VLAN 20 is flapping between port 23 and port 3. Now port 3 is the port that's connecting to our router. 23 at the moment is not connected to anything, or we haven't configured it to be connected to anything at this point. So we just went ahead and put that port into VLAN number 1 here. Alright, so VLAN 1 is the native VLAN. And that took care of that. Then we were not able to reach from router 1, we could not ping to router 3, which is something that we really needed to do, because well, that ping was successful, but we have some more pings up here somewhere that did not work. But we know that the ping between router 1 and router 3 wasn't working. We look at router 3, see right here we had a ping to 10.10.10.1 that did not work. So let's try that again, and now it's working. And in order to fix that, we forgot to actually add our VLAN interface onto switch number 3. So we had VLAN 20 on there, and we had on switch number 3, yeah, we had VLAN 20, we had added, we had VLAN 10. Now if we did a show interface, I probably should have picked that up sooner, with a show interface brief. If we would have done a show IP interface brief, we would have saw that there was no VLAN 10 with an IP address, because this VLAN was not there until I just added it a moment ago, and that was able to give us our end-to-end connectivity, which is what we wanted. We want to be able to reach from this end of the network to that end of the network. Now we know everybody in between should be able to reach, so let's test that too. We like to verify everything. So before we were not able to ping 20.20.20.1, because you see that was all dots. So now we can ping 20.20.20.1 from switch number 2. Switch number 1 could not ping 20.20.20.1 before, and now it can. So we have everything set up correctly. We completed all of our tasks. We resolved all of the trouble tickets that came through. So we're going to copy the config, copy run start on everything, and we're going to go take a lunch break. I want to thank everybody for listening. You have a nice day.